right, everyone. Thank you for joining the latest Trees Around the Globe student research campaign. This is campaign number 95, webinar, I should say, webinar number 95, and this is part of year 8. Today is the State of Trees, July 2026, the STEM Enhancement in Earth Sciences, or SEAS, Summer Intern Program 2026, a new summer of remote sensing research in land cover, vegetation, and more. So today we are going to hear from some of the C students led by Peder Nelson, talking about some of the research presentations that they've been working on and some of the research they've been working on during this summer 2026. I'm going to pass it over to Peder Nelson in a little bit after I do some of the introductions, and we can learn a lot more about what's been going on with the research with Cs this summer. So we're excited to hear about that. And as you know, last month's webinar, the webinar for June 2026, was a discussion about, some past Cs programs to basically build us up to what we're going to talk about and learn about today. So it was a nice setup for last month for this month. So we're excited about to learn about the new really cool things that has been going on this summer with the C students. But before we get there, before we get to the main part of our webinar today, we're going to go through a couple things. I'm going to introduce you to a couple really cool things that we're going to be talking about today and some new things. But as you may know, a couple little advertisements here is you may have been part of the Globe Cup Challenge, which spanned the length of the World Cup, okay, which was the 11th of June through the 19th of July. And basically it was, we wanted you to, as part of Globe, to go out and take air temperature, surface temperature, land cover observations during the entirety of the Globe Cup. And we had it broken down into teams here. You can see these teams. They were based on the globe regions: Africa, Asian, Pacific, Europe and Eurasia, Latin America and Caribbean, North America, Near East, and North Africa. While the Globe Cup Challenge has come to a close, as did the World Cup. Okay, many of you probably watched it. So with that said, we have a Globe Observer Connect event happening in 2 days. So on Thursday, the 30th of July at 12 p.m. Eastern Time, 1600 UTC, the final results and winning teams from the Globe Cup Challenge will be announced. So those of you who submitted data, we're going to be talking about, all the data that has come in from those observations. Okay, during this time frame, where the most of the observations came from, any unique results that we saw. You see this shareable here, where this is a person standing here with their foot on I'm going to say a football, or for the Americans, a soccer ball. Okay, this is a photo that was actually a submission during one of the down photos for land cover, and this was from Nigeria. This was from a citizen scientist in Nigeria. So this picture was used as part of the shareable to advertise this Globe Observer Connect event. So we hope you join us for this. You can go to just this URL down here. Just go to the Globe Observer page, and you'll see it up top. You can find the Globe Observer page up top, or you can go directly to observer.globe.gov/go-connect. And there's a little link there that says register, and you just register via your email, and then you'll get the information of how to join it this Thursday. And we'll be talking to Dr. Eric Branda-Colston, a scientist at the NASA Goddard Space Flight Center in Maryland in the United States, and Dr. Kevin Chikowski from the University of Toledo. They'll be there to discuss results and to answer any questions. And if you participated in taking observations during this time, you can discuss what you learned during the challenge with your observations. So, we're excited for this event, and please come and join us. Now, one other thing I want to mention and announce is that for our campaign for the month of August, we will be having an intensive observation period. And as you know, we've had many of these for our Trees Around the Globe student research campaign. Now, we're calling this one the August 2026 Tree Check Month Intensive Observation Period for Tree Height and Land Cover. And I'll explain what that means in a second. But once again, we are looking for tree height and land cover observations for the entire month of August 2026. And you can go to our campaign IOP page, the intensive observation period page, and there's a lot going on here. But what I did was I went and I grabbed the observations for tree height and land cover and the maps associated with them, the globe visualization system maps. Sorry, there's a lot going on here, and there's a lot of dots here, really small dots, but I grabbed the amount of data that we've gotten each August for the length of the campaign. Since we started on the 15th of September 2018 with the campaign, there's no 2018, of course, because we're talking about August here, but we have 2019 through 2025. And you can see here we've got a lot of observations from each one of these years, and we've primarily gotten a lot of observations coming in for some of these years more than others, because just specifically, if you look at 2023, we have the most observations here, and we had one of our challenges going on, one of our tree challenges going on at that time. So we got a lot of tree height observations during that time. You'll see over almost 2,400 tree height observations during August. So that was part of one of our tree challenges that we were running for Globe and Global Observer at the time. So with that said, there's a lot going on here. You can see this in the recording. Once it gets posted, you can look at this more closely. But you can see right here, we've had over 8,600 tree height observations from almost 3,000 global sites in August from 2019 to 2025. We've had over 5,200 land cover observations from over 3,400 global sites in August. And we've had a combined 13,924 tree height and land cover observations from 6,400 global sites in just August for the life of the campaign. Now, when I say tree check month, and there's a lot going on here, but I highlighted probably too much here in green. But the United States Department of Agriculture around 2021 designated the month of August as tree check month. Okay. So basically what that means is they want you to, August is a good month to check your trees for any, any what's called blight or disease or any pests, any insects that harm trees, things like that. So, they really do a check. And this really stemmed from back in 2021 when we had some issues with some insects that were really boring into trees and causing some issues. So the United States Department of Agriculture issued, for people to go out and check their trees for certain pests. Okay. So they thought, why not just do this every year, have an annual tree check month. And I thought this would be a great time to do an intensive observation period for tree height and land cover to get, closer to your trees and look at the land cover around them and take these observations. So we created this intensive observation period for August. And, we have, our friends always at the Arbor Day Foundation who have really some great resources that can help you through the process and help you understand, what these signs of pests are and, what tree damage to look for. So, we're always looking for, with this campaign, yes, it's a research campaign. It's a student research campaign, but we're always looking at different angles of, when you're doing the research, you're looking at the environment, you're looking at things happening around you, you're looking at everything from, what's affecting the tree, what's affecting the environment around you when you're taking these observations, right? So, this is, I think, a really good, intensive observation period that takes it beyond just the observation. Okay, you're looking at the health of your tree, you're looking at the health of the environment around you as well. So there's a lot going on here, but as you know, with these IOPs, what we do is, when we talk about these observations, these observations serve another purpose. They serve that purpose of comparing it to the NASA satellite data as well. We have the tree, we can compare the tree heights to ICESat-2 and the JEDI mission. We have the Landsat series of satellites that are looking at change over time and land cover. We can do that as well. We can potentially validate the ICESat-2 data, JEDI data, Landsat data with this data, the citizen science data, the crowdsourcing data. So this data that you're providing during the intensive observation period, and anytime you provide the Globe Observer data, that data can potentially be compared to the NASA satellite data, and potentially, and I say potentially because not all the data is going to be able to be compared or, serve as validation data, but it could be, because we've written papers on that. We've written peer-reviewed articles. We've shared those things before with our campaign webinars as well. So as that data serves multiple purposes, for student research, professional research, comparing to satellite data, understanding your environment locally to globally. So the data that we get, from you serves so many different purposes, and understanding our planet better is that overarching purpose, is how we look into it. So feel free to check out that page. There's the URL at the bottom. If you go to our campaign page, if what the webinar page, I'll send this out once we get the recording for this webinar later on today. I'll send an email out that goes out to everyone who's on the list for the campaign, who's on the listserv for the distribution for the campaign webinars. This will go out, and you'll be able to read more about this as well, so you can be part of this intensive observation period for August. All right, so the last few things here before I pass it over to Peter and the C students is that, as you know, we have our campaign. Our most active participants are from around 70 countries across the world. And what I did this time, I highlighted what I want you to take a look at here. We are in year 8 right now, which began on the 1st of October of 2025. And these are our numbers for tree height, land cover, and greening measurements, green up and green down. As you know, green up is in the spring, green down is in the fall or autumn. These are the measurements that we have so far that have come into the Globe database. And then for the life of the campaign, we are at just over 281,000 combined observations for tree height, land cover, and greenings. And that comes from just over 84,100 global sites, and that is as of this morning. And we have a combined, the 95 monthly webinars. Once in a while, we've had 2 a month, but we have 95 of those, quote unquote, monthly webinars. And we've had 40 special campaign webinars. That means that's a total of 135 campaign webinars specifically. And we still have the blogs that are still posted on the Globe website. And the latest count as of today is over 401,000 views of those 83 blogs that are part of the campaign. All right. So the last thing before I pass it over is that this story just came out a few days ago. There's a NASA-funded study, since we're Trees Around the Globe Student Research Campaign. I wanted to share this. But there's a new NASA-funded study that shows how controlled burns help sequoias survive wildfires. We've talked about sequoias in this campaign. So they were focusing on some trees in California, these 19 groves of sequoia trees in Sequoia National Park and Kings Canyon National Park. And basically what they were doing was they were found that the giant sequoias were nearly 4 times more likely to survive extreme wildfires in forests that have been managed with prescribed burns, which decrease tree mortality or death. So these prescribed or controlled burns, which you probably know, help the trees by thinning underbrush. So all that underbrush underneath the trees, the dead wood, and other dry fuels, reducing the likelihood of mortality or death from high intensity wildfires, because that's basically fire fuel, all that underbrush, and that contributes to these, the expansion and the quick moving wildfires, throughout these highly wooded areas. The researchers in this funded study analyzed 26,403 giant sequoias across 19 groves in Sequoia and Kings Canyon National Park in the wake of the 2020-2021 fire seasons, when a record 6.8 million acres burned across California. So devastating. So the team combined LiDAR, which is what ISAT-2 uses, and also JEDI, stem maps from the trees and plants, and then also high resolution imagery and modeling techniques to estimate giant sequoia mortality in relation to forest management practices and found that prescribed burns saved roughly 1,800 giant sequoias. Because as you know, these sequoias are very old, very tall, and historically important to the forested areas. So wanted to showcase this with you. There's more to that story if you want to take a look at it. This is just some highlighted bullet points here that I popped in here. But the story is here. I created a tiny URL because the actual URL was massive. But we'll put that in. I'll put that in the chat after I stop sharing my screen here. But you can read that story here. That was put out, I believe it was the story was on July 21st. NASA put it out on their news brief section in their latest NASA Science News. So I wanted to share that with you all as well. So the next campaign webinar will be the State of Trees, August 2026, revisiting the trees around the globe, tools, resources, and tricks for maximizing student research in land cover, tree, and vegetation science. And that will occur on Tuesday, the 18th of August, 2026. Same time, 1 p.m. Eastern Daylight Time, 1700 UTC, 1900 Central European Summertime. So, you'll get an invite. Those of you on the distribution list, you will get an invite to that very soon. I try not to send that out as I'm sending the ones to the current one out because it can get confusing. So once this one's done, I will be sending out an invite to this one to the listserv, the distribution listserv. So with that said, since we're talking about research, right? So as you know, I always pop up some quotes here to get us in the mood for what we're going to talk about. So everybody knows Albert Einstein, German-born theoretical physicist, and he was also the 1999 Times Person of the Century. I always like this quote: "If we knew what we were doing, it would not be called research, would it?" And then another person that I wasn't really familiar with, but her name's Catherine Howe, American novelist and fellow of the Center for Advanced Study in the Behavioral Sciences at Stanford University. She said, "But an attentive researcher like you might be able to see something that all the experts can't see if she asks the right questions." Like that quote. It's a nice quote. So since we're talking about research, we're going to talk about the research that's been happening with SEAS 2026. So what I'm going to do now, I'm going to pass it over to Peder Nelson, senior instructor and senior faculty research assistant at Oregon State University. And he's been working hard with the SEAS students for 2026. And I'm just going to let Peder take it away. And Peder, I don't remember where I found this picture, but I like this picture of you presenting here. Yeah. So I don't remember even where I found it. I just found it somewhere in my files, so I don't even know, but I like this picture. So I'm going to stop sharing and pass it over to you, Peder. So thank you, Peder, and thank you for all the students, students for being here today.
I appreciate that, Brian. And, that's basically what I was trying to do virtually this summer. So I really appreciate that. And the nice thing is, one of the things that we were able to do this summer that was really unique. And I feel like this was something that was really kind of a breakthrough. So bear with us as we actually forge new ground here. One of the things that is really important when you are doing research, as Brian mentioned there from Einstein, right, is to actually start off with that original search. What did the original people come up with? What is the original data set? What is the methodology that they used? And within the GLOBE program, we have these protocols, which are exactly that. But we don't connect you to why or the article that even defends why you're doing it in the way that you do. So sometimes there's a little bit of a challenge when you are starting a project because you really don't understand that initial search piece of things and why you're even doing what you're doing. So we've been really lucky because as Brian mentioned at the beginning here, last June or a month ago, 4 weeks ago, however many days we actually introduced what we did last summer, and we were really fortunate to have 6 researchers produce some original research using their Globe Observer data that they collected and the satellite data that goes along with those. And what was really wonderful is that developed a methodology that goes from searching all the way to publication. And that publication piece is what allowed us this summer to actually pick up and understand this cycle. And this is, something that we wanted to really model, because this is how we should be doing things going forward. We have data sets. We have people contributing maybe 8 weeks of work, maybe 1 day of work, but we need a way of actually sharing things with each other. And this is where a lot of the digital repositories we've talked about come in. And where do you discover the data that's out there that can help you answer your questions? So that's where we were able to really jump off this year. And so I want to encourage people to go back, watch that webinar. If you want, there are the open source articles that we can share with you. But I want to kick off and actually have one of our authors give us a little introduction about what they did last year, because they were a peer mentor and helped a group of students this year. And so I want to pass it over and bring into our conversation here Nandini, who happened to do a lot of really, I think, cutting edge or breaking the mold sort of approaches. And a lot of that is because of the ways that we're able to do science today. Okay, so the methodology is changing a lot. But Nandini, jump into this conversation and share with us a little bit about what was your C's experience or your research experience like last summer, and importantly, why did it lead to being more involved at all?
So yeah, absolutely. Can you all hear me?
We can.
Great. So last summer, I was an Earth System Explorer C's intern, and we started by using the existing adopt-a-pixel methodology and tried to look at how we could compare globe observer data and observations within our own communities by doing analysis within a specific 3 kilometer by 3 kilometer grid and comparing that specifically to different satellite trips. Now, this is a very interesting project for me to be doing specifically in my area of New York, because I grew up seeing Hurricane Sandy come to my area in 2012. So I remember trees coming down, and actually, if I can share my screen, I could show some part of my paper and part of the community chronicles we did to combine the quantitative and qualitative analysis of our own communities. I think, like right over here, I can show that there are pictures of trees coming down in my own neighborhood. Like this was a tree falling in front of my house because of a very bad thunderstorm. And there was no way to report that. There was no way to document that, to the point that this area, was not properly represented on satellite data. So we worked to compare, using this chart right over here, the different tools, such as ones attached to Landsat, the Sentinel satellites, and we also did analyses over time with the Landsat time series graph. Now, we were able to find about the challenges of the Global Observer app in this process, and additionally, we were able to analyze how much agreement and disagreement there was. So, just in terms of raw data analysis, I counted the agreement and disagreement as measured relatively just with estimation in this case, but now we've been continuing to develop forward with more accurate and quantitatively based confusion matrices. But you can even compare the developed vegetation and water predictions of each tool and show that, for example, the dynamic world and ESRI maps failed to quantify my community well, since being from a suburban area, they kept assuming that it was completely developed and that there was no greenery. However, even in my own analysis through my community chronicles, discussing my own community, I talked to longtime residents in my area who had been living in New Hyde Park, New York since the early 90s, and they were saying that there used to be so many trees that there was just a canopy. You couldn't even see the sun through it. And they estimated about 25 to 30% loss of tree cover over the years. But that's something I didn't really see reflected in the data, except for a small dip after Hurricane Sandy. So with tools overestimating the amount of developed land and not allowing us to accurately quantify, an area that's been known, especially in New York, for how rich in vegetation it is, I think it really taught us to look more deeply at these different tools and look at how these tools update and different ways to explore what's going on in our communities, because I definitely think maybe more damage went unreported during these hurricanes, and going forward we may not be able to actually quantify that damage properly. So that actually motivated me and my group to develop this project called Earthlens, stemming from last year's internship, where we're trying to build off of the existing Globe Observer system from a phone analysis to possibly using a drone and app hybrid system to almost get the best of both worlds between a satellite and between mobile observations. Since a lot of interns reported that it took a very long time to do the observations on their phones, and also the satellite data, as we have previously discussed, was not accurately quantifying a lot of our communities. So that is a currently in progress project that will hopefully use a Raspberry Pi based system that it can connect to an app, and then just add even more data sources. And it's very interesting because I didn't think I was going to end up in environmentally science related things before. I came in with mostly an aerospace interest to the program, but I realized that I think the engineering itself is what attracted me to this specific topic, and it's to the point that even now I'm interning in a environmental sensors community sensing lab in New York. So SEAS was able to give a very powerful experience and help me actually analyze and look better at my community.
I love it. Thank you so much, Nandini. I love, because this was, you really kind of demonstrated how just investigating your community and looking at what data was there, what data is not there, this resolution piece. It was something that I know we really brought up a lot. And I love that, one of the things you highlighted is 2020 wasn't that long ago. We actually had the Globe Observer, right? And so this whole idea that just because we have a tool out there that it's capturing all the data is also really misleading, right? And so, all of this information like this, I really appreciate the way that you put this together. And then, importantly, you wrote it up. And this was kind of that key piece right here. And this confusion matrix part is something that we've been trying to teach people to do in the GLOBE program since the Land Cover Protocol came out, actually. And so there is a whole background about how to do this confusion matrix, how to compare what you do to the satellite measurements. And so I'm not going to spend a lot of time saying how to do this, but it is really interesting, Nandini, because you didn't use the original values. You actually grouped them together to make it a little bit easier to work through, right? And so this developed in vegetation and water classes is one way that you can actually approach this. So this is a really great demonstration.
It was so interesting because actually every different, even World Cover, Dynamic World, and ESRI had their own classifications, especially when we were comparing to Collect Earth Online, because that one differentiated between whether it was like a sidewalk or whether it was a road or whether it was a house. So then we had to simplify it down into all these categories. I think these the sources of all these tools need to communicate with each other a little better. So maybe that's something that needs to be taken into account going forward with that. But I think hopefully we'll be able to do more granular than just develop vegetation and water, but I think that is a limitation we just have with the tools right now.
Yeah, and I think one of the things that's really important to recognize with that is almost every satellite will give you a water and land mask. That's something that they all need to know. And so, so this level of agreement is just it's interesting to see. And again, that just leads to a lot more questions. And so, Nandini, that was the wonderful thing is in 8 weeks you were able to produce a lot of data. Give us all a little sense for how long did it take you to write up this article so that we could use it and people could actually even learn from the methodology, even if they weren't in your particular location?
Yeah, absolutely. I would say that the physical writing in the paper may have been among the easiest parts since we had had so many deliverables completed by the conclusion of the SEAS internship. So we actually had this one of our biggest and most important deliverables was this full chart of our AOI and each of the points there. So once this was established and we had just done check marks indicating agreement or disagreement, from there the confusion matrices were able to just be counted from there. And additionally, we had a presentation in within the SEAS program in the SEAS symposium. So we had already been working with our groups and analyzing some portions of our AOI and the direction that we are going forward in. So I think the paper may not have taken more than a couple of weeks in the writing and revision process, but I I find that the bulk of the work that we did in the 8-week internship made it such that we can do a lot of additional analysis beyond that. And even our data is not, it's not like our data is not usable now that it's been a year. It's that we can still do more things as we learn how to do more things with them. So it's well structured in that you collect so much data, you can recognize what can be done.
Nice. Yeah, excellent, Nandini. And I think, for me, that was what this lesson and really, one of the things that is great about your article is if you scroll down, it shows you the data availability, right? And to me, this is a really important part about our modern science that I just want to keep emphasizing is look right here. These are places and ways that we actually help each other understand how we did things. And importantly, right, Nandini, it wasn't just that your data is sitting in the Globe database, but it is actually in another in this Zenodo website data archive where there's a lot of information. And one of the things is this to me was you helped us to demonstrate modern or make a move into modern science in this way, not just relying on the Globe database, but also these other ways that we're all learning how to share our work like this. So Nandini, I think this was really great. And so, obviously you did a great job here of setting up yourself, but explain to us a little a moment here before I want Brian to play a little video here of what we did this year. But Nandini, what did you end up doing, to continue your work here?
Yeah, so up until the beginning of the SEAS internship this year, I've been working with my group members from all across the country to keep developing our drone. And we actually presented at the AGU conference in December 2025 this year. And we made some amazing connections. We presented as part of the Bright Stars student poster session and had an incredible experience meeting the other SEAS interns and learning from other professionals in the community. So that presentation we did in New Orleans in December. Later, I also presented at the launch of the Next Generation Global Collaboratory as part of CUNY in April in New York City, which was a great way to discuss how powerful Globe has been for me and my group as students, and how it's really been able to actually impact our own career trajectories and research interests. And then I decided to peer mentor the 2026 SEAS intern program because I had such a great time last year, and I knew that there was going to be new tools that Peter and the whole team have been developing, and it'd be great to see how everything's evolving. So I came back as a peer mentor, helped guide our team through we had 5 different working groups. It was me and one other person who were helping guide our working group through their own data analyses and their own confusion matrices, and so that they can hopefully write their own papers. Actually, I think every single intern, you can't see it here, but every single intern has their own drafted paper that we are assisting them with, and then we're trying to help them also write their abstracts for the AGU conference this year. So it's been really great to be able to work and pass it forward while still being able to teach essential team science concepts and keep people motivated to continue their own projects beyond this and stay involved in Globe and the land cover observation community as a whole.
Yeah, thank you, Nandini. I really, for me, I really appreciated, and I know a lot of other people appreciated having an actual author. Rarely do you get to interact with somebody who's written something that you can read, then you can look at their data, you can actually ask them questions. And Nandini, you're just one of many people who came back and offered up your time, to provide that guidance. For me, that was just really, really wonderful. And what is nice to see is we have many of our interns from this year, or I like to think of us all as early career scientists, and so I want to give them a chance to talk a little bit about how we maybe changed things a little bit this year. And just last week, we did do some presentations as groups talking about what we actually did. And so what I'd like is Brian, if you can play one of those videos, that will give everybody here a sense for the type of work that we ended up doing. And then I'll go around and we'll introduce some of the researchers from this year and talk a little bit about what they've been doing and how they've been learning about the current stage of remote sensing science.
Hold on, let me make sure I'm unmuting myself here. I'm gonna start the video. Make sure the sound's coming through because Zoom is a little funky sometimes. Just start real fast here.
Our working group came.
Could you hear that? Okay, cool.
Yes.
Let me make this full screen here so you can see that.
Came together to apply the Adopt a Pixel 3-kilometer field methodology to investigate research questions related to Earth's land cover, land use, and change. Our research domain overlaps with NASA's Land Cover and Land Use Program, where NASA states, the program provides a scientific foundation for understanding the vulnerability and resilience of human land use systems and their interactions with ecosystems. The program enables U.S. researchers to test algorithms, calibrate and validate data, and apply NASA observations in diverse regions of the world for societal benefit. Leveraging local expertise enhances field observations, data accessibility, and the accuracy of satellite-derived products. Monitoring and modeling land cover and land use change, or LUC, focuses on interactions between land use and the water, carbon, and nitrogen cycles, land-atmospheric feedback, impacts on ecosystems, biodiversity, and ecosystem services, wildfires, and sustainable land management. As a group, we began to identify changes in land cover and land use related to extreme earth events and urbanization, and explored map products describing those changes. From there, we identified a research question as outlined by LUC. What are the consequences of changing land use activities for ecosystems, and how do they respond to and affect global environmental change? Each of us conducted our field research locally in our communities, and together we created this land cover timeline. This timeline describes the important dates that emerged from our group research. Our report on research will begin with 1996. Hi, my name is Claire Hood, and my area of interest is far north Dallas. My region's landscape has transformed from rural to heavily suburban. To investigate the effects of this transformation, I created a sampling grid centered at 33.006779 degrees north and negative 96.800979 degrees west and gathered photos at 33 locations using the Globe app. I then compared these photos with existing land cover maps and identified possible reasons for discrepancies. Shifting to a temporal focus on my AOI, a 1996 drought caused a significant drop in greenness, and the following vegetation recovery suggests suburban landscaping. Despite localized greening, broader data revealed rising temperatures, declining land productivity, and loss of non-urban land cover. Moving forward, I hope to use quantitative analysis to validate these suburban landscape trends. Thank you.
My name is Sagan Rapp, and my area of interest is located in Altadena, California. My AOI is located at the coordinates 34.19016 degrees north and negative 118.13132 degrees west. My project investigates the Eden Fire and its impacts on vegetation and land cover, and how accurate satellite data can reflect these changes. To do this, I used the Globe Observer app to collect my own land cover observations and photos at various sampling sites within my area of interest. I then compared my observations with multiple remote sensing datasets, including the Landsat Time Series Explorer imagery, the Landscape Change Monitoring System, or LCMS, Fire Perimeter and NASA Worldview Expert Labeled Damage Point datasets, and aerial thermal imagery to characterize structural destruction, vegetation loss, and landscape scale change. My field observation results can help validate satellite imagery datasets because it shows that they're effective at monitoring change, like broad wildfire impacts. And they can help reveal small-scale differences that satellites can sometimes miss. As I continue my research, I plan on using these observations to gather more quantitative data to understand post-fire landscape recovery.
My name is Natalia Gaunt, and I am presenting my area of interest, Midlothian, Virginia, at the coordinates 37.478 degrees north and negative 77.71 degrees west. Midlothian is a suburban area west of the city of Richmond. The AOI focuses on developing neighborhoods that have high impact on land coverage. Using the Globe app, I collected land cover data for 11 points within my AOI, validating satellite data. The first significant date in my research applies to the area of Midlothian as a whole in 2003, with the addition of Route 288 serving as a catalyst to development in the area. Another notable date was 2013 and 14, when mass construction began in neighborhoods. Findings conclude that quick suburban development has substantial impact on land cover conditions. Continuing my research, I hope to investigate how Midlothian's changes in vegetation may affect the atmospheric composition.
Hi, my name is Dwarka Kumar, and my area of interest is in Cumming, Georgia, a rapidly developing region centered at 34.265 degrees north and negative 84.188 degrees west. Let's first start with the problem. Cumming has had a major drought problem in 2026. I wanted to investigate the role of residential developments in this. To do so, I created a 6x6 area of interest grid for Globe Observer ground observation photos. My investigations brought surprising results. In my AOI, there is decreased tree canopy cover and vegetation browning since 2017, major features of poor environmental health. The collection of burn ratios and vegetation indexes also show the significance of 2017, which is when Cumming's new city plan was approved. Moving forward, I'm looking to further classify my land cover data to support my hypothesis that this 2017 land cover change could have played a major role in causing the drought conditions. Thank you.
Aloha, my name is Chelsea Ann Miguel, and I'm a rising junior. And on August 8, 2023, the wildfires devastated Maui. And I asked the key question, did the 2022 drought quietly predisposition the environment that helped the wildfires thrive? Using different types of satellite data and as well as land cover analysis, I tracked the vegetation health at Pukalani Park, and as well as found the measurable browning countrywide, with wide drought severity and stress that accumulated steadily, one not spiking once but also accumulating over a year before the fire. This supports the conclusion of drought.
Hello, my name is Javi Padilla, and my project investigates land cover change in Long Beach, California. My AOI is centered at 33.831919 degrees north, negative 118.187,195 degrees west. I selected 2016 because it marked the end of California's historic drought, making it an important starting point for studying vegetation, recovery, and urban land cover change. Using field observations and satellite imagery, I investigated how urban development influenced vegetation over time. I expected Long Beach to remain predominantly developed while experiencing localized vegetation change. My results support this hypothesis. The imagery and land cover maps show the area remain mostly developed, while the vegetation graphs show a decline during the drought, followed by gradual recovery. Overall, this research demonstrates how remote sensing and field observations can be combined to monitor land cover change. Thank you.
Hi, I'm Abigail Zacharias, and my area of interest is Fulton, Maryland, located at 39.1538 degrees north and negative 76.9057 degrees west. Since 2003, Fulton has transitioned from farmland to dense suburbia. Despite this development, tree canopy cover has actually increased. Using both ground level and satellite data, I will be investigating this trend. So far, I found that canopy cover has increased at a higher rate since the 2020s. Satellite imaging confirms that the land has been visibly greener in the past 7 years. I also noted that forest cover in Fulton aligns with the county's forest protection areas. From the images, I hypothesized that the 2019 Howard County Forest Protection Act led to significant increases in Fulton tree cover. Moving forward, I plan to conduct quantitative analysis to assess my hypothesis.
My name is Jonathan Ben-Harushgal, and I'm presenting my area of interest, Markham Park in Sunrise, Florida, located at 26.135 degrees north and 80.350 degrees west. Markham Park contains forests, wetlands, lakes, and recreational areas. I compared satellite-derived land cover products to identify how well they represented the different environments within my area of interest. Using the Globe Observer app, I collected land cover observation at 9 locations, providing ground reference data to compare with satellite classifications. My results showed the greatest classification uncertainty in wetlands and shoreline habitats because multiple land cover types often occur within the same satellite pixel. Continuing this research, I hope to determine which satellite product most accurately represents heterogeneous environments like Markham Park and how ground observations can improve the future land cover classification.
My name is Nico, and my AOI is Palo Alto and Mountain View, California. Once a college town and orchard farmland, now a center for tech, my AOI also borders decommissioned salt ponds as part of an ongoing restoration project. Ponds levees are breached, letting tides and sediment flow in, spurring vegetation and wildlife. Included in this project are Pond A6, breached in 2010, and Pond A2W, breached in February 2026. How can remote sensing monitor the transition of salt ponds to tidal marsh? I used qualitative image time lapses, as well as a quantitative analysis of land exposure and vegetation changes. Looking forward, I'm creating an open access framework to monitor marshland restoration using remote sensing. Our time is short, but here are all of our acknowledgements on this slide. Thank you to all of the people and organizations that have made this SEAS internship possible.
This internship has taught me how to read, think, and especially how to write as a researcher by helping me find patterns and connections within the data that I find. My improved research skills have strengthened my confidence in pursuing a bachelor's degree in a scientific field where I can contribute to sustainable solutions. This internship has also inspired me to continue conducting research throughout college and into my future career.
One of the most valuable things I gained from the NASA Seas internship was learning how to use remote sensing datasets to gather information on environmental change. By analyzing satellite imagery and using my own field observations, I learned how scientists can use these datasets to help monitor our planet and its ever-changing landscapes. This internship has been a valuable experience that will serve as a stepping stone in my career, giving me hands-on experience in scientific research, data analysis, and teamwork skills. The peers, mentors, and skills I've gained within this internship will continue to support my goal of pursuing graduate studies and finding solutions towards the climate crisis.
As a Seas intern, I learned the importance of citizen science and how to improve my data analysis abilities. These skills will assist me in my long-term goals of continuing interactive research and pursuing a degree in engineering. A challenge I faced was cross-referencing many data sources, but this ultimately strengthened my ability to assess information from a variety of perspectives. Also, using new software was initially difficult to navigate, but I learned to communicate my confusions with my team and quickly adapt to new methods of researching.
Throughout this internship, I developed a more key fundamental relationship within the land of Hawaii. I also effectively communicated within my working group. This internship helped made me choose and think about remote sensing as a per- career path, and as well as become more involved within biochemical engineering and the coding programming process within research.
During my internship in SCCs, I learned how to combine satellite imagery with field observations in order to improve my work, but also just pulling from different sources and verifying my work and my research in order to have a more accurate and informative answer. And this has really influenced me to pursue my desire in obtaining a bachelor's degree in environmental engineering and exploring a career in sustainability.
Before Seas, I saw satellite imagery as a way to observe Earth's surface. Throughout this internship, I learned that the most meaningful environmental research comes from combining satellite data with field observations and careful analysis. Working with new mapping tools and validating my own data changed the way I approached scientific research. Looking towards 2031, I hope to apply these experiences into research in aerospace engineering, remote sensing, and artificial intelligence, developing technologies that help us better understand and protect our changing planet.
Through the Seas internship, I have seen how accessible NASA data is. I will definitely use this data in my future for either academics or out of curiosity. I plan to pursue a graduate level degree in a physics field by 2032, so I now know where to find satellite data for future projects. The biggest challenge I faced in this process was searching for the right topic and finding a clear trend to investigate. From Seas, I have learned how to find a research question that truly interests me, which is a skill I will be using for the rest of my life.
From my Seas experience, I've learned more about how to use GIS tools and extract data. This will make me a better data analyst in the future, 2034 to be specific. It has also helped my critical thinking and research skills. Some challenges I've experienced in this internship include glitchy Zoom calls and a tough experience extracting data from the land cover monitoring system tool. Yet I've overcome these while also getting new learnings for research organization and teamwork. This has made my Seas experience extremely valuable and informative.
One important thing Seas taught me was the importance of remote sensing. I learned remote sensing can often be faster, cheaper, and sometimes more accurate than on-the-ground work. I've learned to look at questions with a remote sensing lens, often finding new and unique answers. Seas has also changed my career goals. I've always been interested in science, but Seas opened up my eyes to research. I'm sure that no matter where I end up, I will be doing some sort of research or citizen science.
This is our team timeline slide based on our individual reflections mentioned earlier. This provides the connection between our current research and future careers, which shows why NASA Seas has truly been a valuable and insightful experience for us all. Thank you for listening to our presentation.
Thank you, Brian, for playing that. And what's really wonderful is that we do have several of the researchers, the early career scientists here available to answer some of your questions from the people who've decided to join us outside of our immediate group. We've been working together and we know each other pretty well and what's been going on. And so, one of the things that I will just ask is, everybody kind of mentioned, you were learning new tools, and you are also running into some problems. You had to do teamwork. And so I'd like to just go across and start off with Lima, and bring you into the conversation. And what was this experience like for you, or how can yeah, where are you kind of going with this? What did you take away from this experience?
Hi everyone. Can I talk about my AOI and like what I've
Please do,
done?
Lima. Yeah.
So I don't know if you guys know me, but my name is Damon Hayes, and my project kind of explores how suburban development has influenced land cover and vegetation in Woodbridge, Virginia from 2000 to 2025. Mine wasn't really shown, I don't really know. Um, I chose this area because I live really nearby, and over the years, I've really watched new neighborhoods, roads, businesses, like they constantly disappear, and it really wanted me. It was really, I was really curious to see how those changes can be measured, and I wanted to do that using remote sensing data. And so from that, I used like Landsat imagery to compare those landscape changes over time. The NDVI, I think a lot of people did use those, and to track overall vegetation greenness, and of course the Google Earth. And then when I found this, my results showed that while development continued to expand throughout the area, the overall NDVI remained relatively stable. And so moving forward, I'd love to build on this by adding other data sets that we talked about previously in other meetings, like impervious surface and land cover classification, I think it was. So I can measure exactly how development occurred and what types of land cover changed over time. And overall, to me, this was an incredible experience. I got to learn so much about research, got to meet so many new people, and it was super, super exciting.
Oh, that is so wonderful, Lima. And importantly, you did create a data set that other people can pick up on and we can
Yeah.
use to help answer some of those questions. So, I really appreciate all that effort that you put in, and the whole piece of research. Have you had any experience doing this before you came and joined our team?
No, I actually haven't, but I've been trying to do a lot of research before I came into NASA about remote sensing data and classifications and cover change and vegetation cover change. So this was really exciting for me to like learn new things and even YouTube things because I was kind of late into the program, so I had to go up and search tutorials for everything, but it was super exciting.
Yeah, and thanks for that, Lima, because one of the things that I think is important is that we're sort of demonstrating what a small group of selected people can work on. But as you mentioned, Lima, all of this information is available to everybody. And the big key is having that time or finding that community that can help you support yourself and move forward in that. And so for me, that's the big thing that everybody here had was the time to sort of dig into this. And so I'm looking forward to Lima. I'm looking forward to your article as well. That to me is a really important part of our science work, right? Is making sure that other people learn from that. So thank you so much, Lima, for all your effort this summer and everything that you did.
Thank you so much.
Yeah. Grant, I want to bring you into our conversation here because we didn't see you in that video. And so we haven't heard what brought you into this program and what did you end up studying this summer?
So I found the opportunity. I've really been interested in remote sensing and geospatial tech. That's a career I want to pursue. So I found NASA Seas and I loved it. I had some previous experience, but I mean, this really taught me kind of from the ground up how to pursue research and in remote sensing. And so my area of interest was Fulshire, Texas. Actually, could I share my screen? I'm a community partner.
Yeah, go for it.
I'd love to show you all this. And so one of the unique things about where I live is it's the fastest growing city in America. I can show you this population graph. It had been fairly steady at around 1,000 for about almost 2 centuries. And so the past 10 years where we've experienced insane growth, and we're now from 1,000 to about 73,000 residents today. Um, and so I'm in a really unique spot to study how rapid urbanization affects the land cover, environmental quality, vegetation. And so this is just an example. This is from 2000 to 2022. Just and it's kind of insane. Uh,
Wow.
and I mean, you could kind of like even in 2010, it would pull up. It would be basically still grass fields and agriculture. Um, but it is actually insane how much growth there's been. And this is just one of the major subdivisions. There's all this development over here that is not shown. And so I chose my neighborhood as my area of interest, which is down here. And I found something really interesting that the vegetation index didn't really decrease as I expected, but that was because the area that I actually live in has a huge fees and just restrictions on cutting down trees because I live in it's a historic pecan orchard. But if you expand the area of interest to an overall, the entire city by 4 kilometers by 4 kilometers, you see the overall decrease, which would be expected. And so that was probably the most interesting thing I found out that I learned about this kind of really unique area that is kind of preserved using sustainable development, but the rest of Fulshire has not. And you can see with the tree canopy cover decrease like this, the area of interest right here is fairly stable, but the rest of it is very much not. One of the kind of future areas of study that I'm looking at with the American Geophysical Union as we prepare our team presentation is some other partners in my group have experienced similar issues where classifications of land cover are incorrect in Fulshire. One of the unique things as we were just starting gathering our data and creating a confusion matrix, I found out that a large portion of my town is still classified as agriculture, which is very much not true. Um, and just looking at why these reasons, why this happens, and using machine learning to combine with actual globe observations to help correct that data and fine tune those models, especially where there's extreme rapid growth. And so, yeah, that was kind of my overall area of interest. So let me know if you guys have any questions, but that's kind of what I've
Wow.
been doing this summer.
Grant, that is just an incredible story. I mean, again, it really points to how, things might not be going on in an area, and you don't think that what you've been doing is really important, or maybe you've been making the same measurement, you're getting the same thing over and over and over again. And now, wow, like that, you cannot recreate the past, right? Like this is completely gone. And I love the point that you really highlighted there of sort of the impact of land use or sort of these decisions that people put on are in the data, but why they're in the data is that big question, right? Like why one area has that historic pecan trees, like you were saying, and other areas don't have that. That age of those trees are really that's just a fascinating question that, Grant, you've really given us something to watch out for in the future, haven't you?
Yes, sir.
I have to say, I'm really impressed with this. And Grant, this is just kind of one of these things that, you might have had this feeling, or things like that. Like, okay,
Definitely.
there's some changes happening, right? But to see the extent and the way, and also I think what's interesting is it's not evenly happening across your area. And that scale piece is a really important one that you really highlighted that I think is really interesting is that one area might be staying sort of the same. It might stay be green and it's been green for 100 years, but the areas all around it have experienced something very different. And so that whole idea of one pixel doesn't represent the whole area is another really great lesson that I appreciate that you brought to us with this talk right here. And like I just said about Lima's, I'm really looking forward to this one because you've already pulled together a lot of really good evidence here that I just think it sets up a lot of questions and also a lot of students in the area who might now have or need a reason to keep doing the research. And you've given us that foundation, Grant.
Yes, sir. Thank you so much.
Yeah, this is, I mean, again, to me, this is a great way of sort of demonstrating how you don't have to go far to see some really interesting stories and events. And that to me is just really a special thing that we've been able to do together here. So I'd like to, if you do have any questions, let's see. I'm going to go over into our chat and just sort of, double check to see if we have any big questions popping up. But I think, to me, what I'm finding interesting is, Zachary, I want to bring you into this conversation because you and I have had some meetings over the summer. And so describe to us a little bit of what you've been, seeing and finding out this summer in your work.
Yeah, so my AOI is in a fully urban area. I'm from the city of Miami, and my entire city is urban. Can I show part of my
You
story map?
can. Yeah.
Okay, I think this will. Okay, so the change in my area from satellite imagery is definitely nowhere near as impressive as Grant's, but like you can see, the red here signifies urban areas, and my entire city has remained urban for decades. But that doesn't tell the full story. So I've noticed this is a major limitation with satellite data is it doesn't have that vertical aspect to it. So my city, for example, here is an image of downtown Miami in 1985, and then this is an image of it in the present day. So there's been significant, so while both of these images from a satellite perspective might seem as both urban, there's a much bigger difference, which is the vertical growth of the buildings. And a lot of this has to do with population density. So my city, the city of Miami has kept the same boundary since the 1920s. It hasn't increased, and the amount of land space is 36 square miles, and it hasn't changed either, which means that any increase in population has since 1920 has to mean an increase in population density. So the furthest back I could find a population density map for was 1975. So this is an image of that. And then this is the population density in 2025. So the darker pink signifies more people per square kilometer and in the thousands. And so there has been this explosive growth since the 1920s. So in 1920, the population was 29,571, and now it's 442,000, more than that. So what I think was really interesting about my research is how I had to look into like population density maps, and I had to look into how the population has changed to get a better understanding of the actual land cover change. So what I think would be really useful and something I want to look into researching in the future is how we can build a data set of vertical urban expansion. Because a lot of the land cover data sets we have now, they just show this area here is red for urban and then this area is green for forest, but that doesn't tell the full story. So that's probably the most interesting thing I found from my research. That's what I just really wanted to show.
Definitely. And Zach, this is one of these things that, here we're talking about trees around the globe. And I think one of the things that we've highlighted is how in an urban area like this, those street trees, and you can even see them in between, there's trees in there that are just not getting calculated at all because they're just lost because of the shadow or a variety of reasons, right? And
Yeah.
and so to me, that's just one of the things that when I see these two side by side like that, right? I definitely see even a small amount of tree cover, tree growth, and some changes related to that landscaping piece. And I think in that way, like it's very similar to what Grant was sort of talking about is, that just because humans build things it doesn't mean that they don't bring a green part into that infrastructure and what they're doing. And to me, that this vertical piece is a really important part that I know we've talked, Brian and I have talked a lot about this, that, whether you're measuring a tree height or whether you're measuring building height, that vertical structure really seems to be an important part of what we're missing right now. And so whether it's coming from those trees or whether it's coming from the buildings, I really appreciate this, Zach, because I didn't appreciate actually some of the challenges that you have in your area, and also how do we do this effectively?
Yeah, and also, so looking into satellite three-dimensional data, because some satellites are capable of it, but the problem is because of the height that they operate at, they have to use lower frequency uh, radio waves, and so the problem with that is that it decreases the precision of the measurement. And
Yeah.
so that's why what we need really more of is airborne LiDAR. So like data taken using LiDAR laser shot down from airplanes, because then we can get that higher resolution by being closer to the ground. So which is why satellites are great for measuring if you want to see how high a mountain is and these really big expansive areas. But if you want to know how how dense the city is in the building heights, it's harder to see that using satellite data, which is also another limitation is the scale of it.
Yeah. Yeah. And we've talked about that, a 20-meter laser footprint, right? It actually might not be what you need in this sort of environment. And so, I hope everybody here is sort of getting an appreciation for the variety of geography that we've been able to explore this summer as well. Luckily, Claire and Dwarka, you both are here, and we luckily were able to hear a little bit of what you guys were doing this summer. And so you've given us some good ideas about what you guys have been researching. But I'd like to hear from you first, Claire, but then I'd like to bring you in, Dwarka. How have you, like, what is the technology or the software? Like, how have you thought about answering these questions? Because, we see a lot of great things on screens, but then I know, Claire, you had the experience where it's like, how do I actually do this? So describe to us a little bit about that software engineering part of your life this summer.
Oh yeah, for sure. I would love to talk about that. Do you mind if I share my screen?
Please do.
Okay. Yes. So this was actually one of the challenging parts, but one of the things that I think I learned the most from. And it was actually really fun, like going through all this thing. So basically, I've already given my presentation on my AOI, it's Far North Dallas. And this is the poster from the video that I gave, of course. But then one of the things that I wanted to focus on after this presentation was the quantitative analysis, the data that we actually got and like validating, like using our observations to match these land cover map producers data. So the way I did this was using the adopt a pixel 3 kilometer method, where we would label these. So we split it into 36 PSUs, each one with 100 SSUs. And so that gave us a total of 3,600 SSUs, where we used the Esri world imagery sort of reference map. And whenever there was confusion, we would reference our globe photos, because each one of these PSUs corresponded with a location where we took field observations using the Globe Observer app. So those photos gave us a really great way to make sure that what we're seeing in this visual satellite map is what's actually on the ground. And so one of the things that I did, which kind of made my life a little bit more difficult, but in the end proved to give me more insights than I thought I could ever see, was I used the USFS LCMS land cover reference map, map legend, because I was intending on comparing it to the LCMS map producer. Actually, this created some challenges for me, because I noticed that if you look over here at the label palette, this land cover legend includes mixed pixel classifications, while the actual LCMS map does not include mixed pixel classifications. So when I went to use the HTML tool that was created for analyzing this, it did not work, because I could not map it to every mixed pixel to the correct like LCMS class. So instead of just relabeling everything, because it might take a while, I decided, all right, I'm gonna try and like use Google Earth Engine to compare my data to like a bunch of other land cover maps. So the way I went about doing this was, and I definitely consulted artificial intelligence for this, because again, those tools are there. But again, I do not have access to the paid subscriptions, so I'm using the free software. So I kind of did like a little jump around, like when one software ran out, I ran to the next one. But it was really helpful, and I actually learned a lot about Google Earth Engine. So yes, I already talked about the confusion with that. So I decided to try every combination of merging the 3 mixed pixel classifications used in step 2, which is labeling with the labeler. And so I got 8 different combinations, basically converting barren and tree mix to either barren or tree, and then the barren and grass mix to either grass or barren. And so that would mean 8 different combinations. And I used a Google Earth Engine loop to go through all of these. Yes. And so that's where I got a lot of information from there. Then after doing that, I was like, I want a way to visualize this, because even though like I don't know about you, but this is pretty, hard to understand. So I decided to try and create an HTML tool that could help me understand this. So let me see. Oh yeah, and the first map that I compared this to was the LCMS map, of course, because I labeled with LCMS reference tools. So I did that. And I used 2023 and 2025 LCMS maps because they have multiple different years. And so overall, this is what I found. So I think the overall accuracy for 2023, they were both around 0.42 for the kappa, Cohen's kappa, which is kind of like an accuracy value, but it takes into account like random chance. And then overall accuracy, if you can see, overall accuracy is here on the bottom while kappa is here, ranged from all the way to like very, very low to very, very high. And then over here, this HTML actually just showed like the percentages of what was classified. And then here's like the golden standard. What I was looking to show was the confusion matrix, because that's the whole point. We want to see where it's right and where it's wrong. And so this is version 4, because version 4 was converting. Sorry, I know I'm like going between tabs and everything. Version 4 was barren and tree to barren, barren and grass to barren, and grass and tree to grass. So that sort of shows that it was the most accurate when it was predicting more barren, which is basically urban. So that shows that LCMS is predicting more urban than trees and grass. And so as you can see here, trees, there was agreement 419, and then agreement 416 with grass and herb, and then barren and pervious agreed. Obviously, there's a lot of urban stuff in my community because I'm in Dallas. If you don't know Dallas, DFW is the fastest growing area in the southern U.S. I'm pretty sure. So yeah, there's a lot of urbanization going on over here. And yes, and then from here, we create this created like, there's a red outline. This is the 36 PSUs and red outline over every disagreement between, this is the between my labeling and the map producer data. And then this just goes through like the percentage in each PSU. And yeah, and then I did a similar thing with 2025. And if you look at 2025, I believe, so now this is another thing we noticed, that there was more higher kappa values in 2025 and higher accuracy values, because you can see this one goes all the way past 0.5 and this one goes just below it. I mean, just like not as high. And so that was really interesting. So I think the 2025 was more accurate than the 2023. So from there, I also wanted to compare, I'm going to try and speed this up because I'm going a little slow here. I also decided to compare LCMS with my label points with Dynamic World, because Dynamic World does probability bands. So I tried this, and basically we got, because Dynamic World allows you to look through tons of years from 2015 to 2025, which was like a lot more time than just 2023 and 2025. And so we saw that while the overall accuracy remained mostly the same, also for this one, I tried to use this one for the mixed pixel classifications, because Dynamic World does a probability band thing where it's like 20% certain it's this, 30% certain it's this. And so I tried to do where the top two probabilities, if it had the top two probabilities in a certain, let me go to the confusion matrix. They were pretty low kappa values, so not sure if this is because, again, the mixed pixel classifications really made things difficult, or if it's just the actual dynamic world land cover map. And another thing is the LCMS is 30 meters by 30 meters, which really created spatial resolution difficulties. And so you can go here. Here's the confusion matrix. So
Yeah.
it was very interesting. Yeah. And then I also compared with world cover, and then I compared people who had used the 10 working class, and I found that their data was actually better used because they didn't use the mixed pixel classification compared with world cover and stuff. Yeah, sorry, I'll stop there. I know it's just going through a bunch of stuff. Sorry.
No, I really appreciate this, Claire, because this is really kind of where we're at with our science right now. And I want to stress that to everybody out there is that this right here, this evaluation of these map products, just seeing how they compare to and describe your location is a giant challenge. And Claire, you really highlighted one, a really cool tool. I mean, you've managed to figure this out on your own, and dig into some ways of visualizing this. And so I want to kind of stress this was one of the big things that we're experimenting with. And so help us join in and figure out, like, how do we actually visualize 10-meter maps and data on the ground? What does that mean? And how does that compare to some of the other historical data that wasn't collected in using this new technology? And so, Claire, I'm looking forward to your paper as well, because you have these, to me, a really slick and useful thing, which is HTML files. We're not talking about anything sophisticated with like Earth Engine or anything else like that. And so to me, that was something that every single one of you, and I know, Dworka, I want to bring you into this as kind of the end piece here, is, that's a new way that I haven't seen anybody in our conversations in 95 webinars really talk about an HTML as an easy way of being able to see our data. So, Claire, I want to say thank you for bringing that into our conversation, because it's really, really important to think about. It's not always, these fancy tools that are out there. There's other ways of maybe doing it, and that's part of our methodology as well. So continue that hard work, and I'm looking forward to seeing that code and sharing that with the rest of us when you get that done. So, Dworka, I want to bring you into this conversation because, to kind of end things, you were in some of these conversations with Claire, and you were sort of trying to do very similar work. And you kind of took a similar approach as Claire of, hey, there's these tools that are out there, and how do I use them to actually make some of these things that I, gave you or that you were trying to do? How did you approach this to make this work? And I'll give you 2 minutes.
Yeah. Okay. So I'll just share my screen. It'll be very, very quick. I'll try to do it as fast as I can. So, okay. So first, similar to Claire, I labeled my points using the labeler that Peter designed for us. It was in HTML. And so I used 10 class from the start, so I did not have to face the problems that Claire did. However, I then was working with this tool that Peter initially was using, implemented for us as the fourth final step for analysis. So I first found a problem with importing the CSV. There was some issue with some labels. So I first tried to design a CSV that would potentially work for it, but then it stripped all the data from that. So then in the end, Peter and I were able to debug this, at least for my test case. And then I was able to find some results, which I will show here. So here were some of my results. This is my Geoga draft article. From what I found, we specifically analyzed world cover. And in world cover, my region was specifically misclassified a lot as a high tree cover and grassland with like a low built up and bare regions. That's primarily because Cumming, Georgia is a very rapidly developing region. Its population has skyrocketed over the past 5 years. A lot of residential communities have been approved. So that makes sense. And again, 11% mismatch is really key here for the built up regions, which is just crazy. But from what I found, just as an initial test, was that my 10 class classifications were, some of it wasn't clearly accurate, potentially because of mischaracterized labels. So I then fixed those, especially for water and shrubland, because shrubland I classified as shrubland for world cover, but in the end I reclassified it as tree because that's how the region worked. And so here is my confusion matrix. As you can see here, I was overall able to get a 68.1% accuracy, which is a 6% improvement compared to my initial run. My kappa value was calculated to be 0.467, which is, again, accuracy gaps in world cover data, but it's more accurate than random classification, which is from like 0.1 to 0.4. So this is much better progression with this tool. Further on, I think we can maybe edit this tool to perhaps even create more results. And then we were able to create some scatter plot models using this tool. And so if it's above the line, that means it's overestimations. And if it's below the line, it's underestimations. And so these 29 points were primary sampling unit fractions of the region of interest. So in the end, a lot of these points fell below. So they were severe underestimations of how many built-up regions were in the area, which justifies the urban development that I was previously mentioning in the video, and the drought conditions being potentially ignored until it's reached like level 1 and level 2 characterizations in the state of Georgia. And I'm pretty sure this is what this has been neglected in environmental policy, which is what I want to investigate further on in my journey in this research program. So yeah.
Oh, that is wonderful, Dworka. Thank you so much for showing us results. I mean, to me, I just want I want to say thank you to everybody here for showing up today and giving us some insights into, to me, current science methods and places that we're experimenting, and that there's a lot of places for improvement and also communication. And so I really, I want to encourage everybody to, watch out for these articles and everything that we're summarizing here from this current work. And I also hope that other people will share some of their new methods and the ways that they're operating here, because nobody's done it like this before. And so we're all learning together. And so, thank you all for, coming and sharing this. And I hope, that other people will continue to pay attention and continue to research what you guys have done here. And with that, I want to turn it back over to Brian and have you wrap us up for our 95th Trees Around the Globe student research campaign. And and I think next month is a great time where we'll dig into some of these tools and highlight how they might even be able to be used in this upcoming school year, right?
Yep. Yeah. All I can say is, wow. I mean, what an amazing group of C students this summer, and great work, Peter, and great work, students. I'm still trying to process everything I saw, especially in the 14-minute video, how rapidly everything went through, and just all the research that went on in that short amount of time that they've been working on this, which is mind blowing to me. And I've been texting some colleagues of mine, and in the chat, seeing all this gives me so much hope for science and research and everything, with the amazing minds that I'm seeing here and the research that's being done. So amazing job. So great work, everyone. So yeah, and as Peter mentioned, this sets us up well for some of those tools, the tools that we've been focusing on in the last 8 years, specifically, I should say in the last several years, a little more in depth, really focusing on those tools that we've been highlighting. really highlighting in the last few years, the online tools, whether it be some of the things that some of the students here today mentioned, whether it's, Worldview or, some of the things like Collect Earth or, Google Earth Engine, some of the things that are being used and used for the research, the data analysis, looking at, that satellite data. And I know one of the students mentioned, the importance of the remote sensing and, how much, more accurate it can be, and it, often is than, the ground-based observations. But, and a lot of you, of course, took your observations on the ground with the Globe Observer, and then we're comparing them to the space-based data, whether it be, the Landsat data looking at land cover, or some people looking at the ICESat-2 data or the JEDI data for tree height. And now we have a lot of those other amazing missions in space night right now, like NISAR and, and PACE and SWAT and all those other missions here at NASA that are taking, amazing measurements, of Earth observation. So, that sets us up nicely for the August 18th webinar coming up, and the online tools to, analyze the data that we're getting from the ground, we're getting from space, and from these amazing group of satellites, and comparing it and using that Globe Observer data, to the citizen science data, the crowdsourcing data, to compare to and validate that satellite data. So we're looking forward to that webinar, and our campaign team's going to be talking next week a bit about that webinar, and the exact direction that we're going to go with that webinar on the 18th. So thank you all for presenting today, discussing everything you're doing, and what you're doing with the research and what you want to do in the future with it. And so thank you all so much, and hope some of you students come in if you can on the 18th. That would be great. I know Peter will get that information to you if you'd like it. As far as connection, it's going to be the same connection information on the 18th at the same time. So feel free to join us. But I'm sure Peter can send you a reminder of the webinar information. So thank you all for being here, and thank you all for joining. So until next time, thank you, and everyone take care and be safe.